In this video, let's take a look at 10.2 Intro to Probability. Probability theory was initially developed in 1654 in a series of letters between two French mathematicians, Blaise Pascal and Pierre de Fermat, as a means of determining the fairness of games. It is still used today to make sure that casino customers lose more money than they win, and in many other areas, including settling insurance rates. At the heart of probability theory is randomness. Rolling a die, flipping a coin, drawing a card, and spinning a game board spinner are examples of random processes. In a random process, no individual event is predictable, even though the long-range pattern of many individual events often is predictable. So we have two types of probability. The first one is experimental. So the probabilities are determined based on real-world data. For example, the probability a driver gets into a car accident. Hopefully pretty low. And then the second is theoretical. Theoretical are determined without real-world data. So the probabilities are determined without real-world data. So for example, rolling a die. What is the probability of rolling a 3? Well, that would be 1 out of 6. You don't need to collect data to know this. So when we're calculating probabilities of something happening, the something is called an event, and the probability of the event happening is written as this, P, and then parentheses, whatever that event is. So example 1A, it says the probability of rolling a 3 on a die would be written like this. Probability rolling a 3 on a die. Or the probability of winning the lottery, probability of winning the lottery. Probabilities are always expressed as a number between 0 and 1. The probability of an event that is certain to happen is 1, while the probability of an impossible event is 0. To calculate a probability, you count the total number of ways an event can happen and divide this number by the total number of possible outcomes. The probability of an event is this: the number of ways an event can happen divided by the total number of possible outcomes. This is what you need to know. Okay, let's go through some examples. Example 2, it says a bag contains 4 blue marbles, 6 green marbles, and 3 yellow marbles. So we have how many total marbles? Total of 13. 4 plus 6 plus 3, 13. A marble is drawn at random from the bag. What is the probability of drawing a green? So we want the probability of a green. Well, there are 6 green out of a total of 13. If you divide this in your calculator, that's going to give you approximately 0.462. Remember, this number is going to be between 0 and 1. What's the probability of not drawing a yellow marble? Probability of not yellow Well, let's see. If I have a total of 13 and I have 3 yellows, then 10 are not yellow. So 10 out of 13, which is approximately 0.769. What is the probability of drawing a green or a yellow marble? Well, that means we have two options. Probability of green or yellow. Well, let's add those two up. We have 6 green, 3 yellow. That's a total of 9 out of 13, and that is approximately 0.693. When you see this word or, you need to think of the addition rule. You just add the two numbers. Examples of experimental probability. Example 3, it says, suppose a study of car accidents and drivers who use mobile phones produce the following data. This type of table is called a contingency or two-way table. The total number of people in the sample is, well, that would be a total of 755. The row totals are 325 and 430. The column totals are 70 and 685. So this 325 and 430, those are your row totals. And the 70 and 685, those are your column totals. Says notice that 325 and 430 equal 755, and 70 and 685 also equal 755. So let's calculate the following probabilities using the table above. And the way we'll do this is we'll start with this guy. This is our numerator. This is the event. So the probably a driver is a mobile phone user. So out of the number of mobile phone users, which is 755, I don't know why I made that line so big. Try that again. How many are drivers? Well, driver using a mobile phone, 325. And in the calculator, this is going to reduce to about 0.430. Okay, next up, a driver had no accident in the last year. So how many drivers had no accidents in the last year? So we have a total of 755 drivers, and no accident in the last year, let's see, that would be 685. That's how many did not have an accident in the last year. In a calculator, this reduces to about 0.907, so that's pretty good. And the last one, a driver using a mobile phone had, and then no accident in the last year. Okay, so this time our denominator is a driver using a mobile phone. So drivers using mobile phones is 325. Had no accident in the last year, that would be 280. So this is 280 over 325. And if you put that in a calculator, that's about 0.62. And that's